Okay, so in this video we will talk about a proof which is very important in discrete math, which says that the prime factorization of any integer is actually unique. So we'll start by a lemma which says that if GCD of two numbers is 1 and one of them divides a product of the other number and another integer. So then we have two numbers a and b whose GCD is 1, and then a divides b times c, where c is an integer. Then a divides c. Now the proof of this lemma actually uses the fact that a GCD of a and b can be written as a linear combination of a and b. So this can be written as a times s plus b times t when s and t are some integers. Okay, so the proof of this lemma, the proof of this statement that the GCD can be written as a linear combination is a little bit involved, and we'll postpone it to a later stage, but we'll make use of this right now. Okay, so we'll not make a use of this, but we'll make a use of this statement that if GCD of a and b is 1 and a divides b times c, then a divides c. Okay, so let's start. Let's say that we have an integer n. So we will prove by contradiction here. So we'll say that it has a prime factorization p1, p2 up to pk, and it has another prime factorization which is q1, q2 up to ql. Okay, so these two are the prime factorizations which are different, and these both products are giving us the value of n. Okay, now our first step is, so remove the common primes. So it is possible that there are some primes which are common in the first factorization and in the second factorizations. So once we remove them, so we are left with pi1, pi2 up to pij, not j, u. This is equal to qj1, qj2 up to qjv. Okay, now let's say that our pi1 is our a, the rest of this is some maybe x, some integer x, and then this guy is our b, and this guy is our c. Okay, so in this case we can get ax is equal to b times c. Now since a times some integer is the product bc, which means that a divides bc. Okay, so as a simple example, if 2 times 4 is 8, then this means that 2 divides 8, right? So this 8 is corresponding to our bc, x is corresponding to our 4, and a is corresponding to our 2. Okay, so this was just an example. Okay, now the question is, what is GCD of a and b? Now a is what? So this is equal to GCD of pi1, and b is what? qj1, qj2 up to qjv minus 1. Why v minus 1? Because qjv is our c. Okay, now what is, since pi1 is a prime, and all these qj1 up to qjv minus 1 are primes which are different than pi1. So since p1 is prime and all of them are prime, all of this qj1 up to qjv minus 1 is prime, then this GCD should be equal to 1. Now we go back to our initial lemma. Now we have GCD of two numbers. So GCD of, I'll write it again, PI1 and QJ1, QJ2 up to QJV minus 1. This is equal to 1. And PI1 divides QJ1, QJ2 up to QJV minus 1 times QJV. Then this means, by the lemma we studied in the start, this means that PI1 divides QJV. But this is not possible because PI1 is a prime and QJV is a different prime. So this means we can say that prime divides another prime, which is not possible. So this means, what did we say about the contradiction? That once we assume something and prove something universal, which is universally known to be true, as not true, then this means our initial assumption was false. So what was our initial assumption? So this means n has only one prime factorization, or you can say a unique prime factorization. So this result is very important to understand, especially in discrete math. So this is it for this video. Hope you like it. Thanks for watching.